Okay, guys, here's F2, more L'Hopital's rule. So L'Hopital's rule continued. I'm just going to jump right into two problems from the practice. So this is number 2 from the practice. Number 2 from the practice, I wrote down the limit we're taking, but we are referring to this graph to figure it out, okay? And the directions. For each limit, you are either given a table or graph for the function f. Evaluate the indicated limit. If direct substitution results in an indeterminate form, okay, that would be 0 over 0 or infinity over infinity, then you must use L'Hopital's rule. Okay, so first we try direct substitution. So when I'm direct substituting, the 2 is going in for the x. So this ends up being f of 4 plus 2 over 10 minus 10. So you know that the denominator is 0, but we can't use L'Hopital's rule unless the numerator is also 0. So for f of 4, we need to look at this graph. This is the graph of f. So f of 4. So I go over to 4. So f of 4 is negative 2. Yeah, so this is negative 2 plus 2. It is 0 over 0. All right. Therefore, by L'Hopital's rule, remember you could say by LHR when you're doing your practice. Okay. All right, and then this is an optional step here, but I'm going to say, just so we keep remembering what L'Hopital's rule says. Okay, instead of saying, I'll say just D. So derivative of the top. All right, I'm just doing it instead of the brackets. All right, so this is an optional step. Optional step. Okay, and I'll just say, so D top, that's the same as going like this. All right. It's just a little bit easier to just write a D. Okay, so this is equal to that. So I got to do the derivative of the top over the derivative of the bottom. So this is the limit as x approaches 2. All right, so the derivative of the bottom is pretty easy. 5x minus 10, that derivative is 5. Derivative of the top. For this one, I need chain rule. For this term, the derivative is just going to be 0. So this is just like a little aside. All right, 2x is the inside, f of blank is the outside. Derivative of 2x is 2. The derivative of f of blank is f prime of blank, and then 2x goes back in. So 2 f prime of 2x. All right, and then you try direct substitution again. So this is 2 f prime of 4 over 5. Okay, looks like it's gonna work. But here is the thing, guys. So we know that f of 4 is negative 2. But what is f prime of 4? All right, f prime of 4, that's going to be the slope. All right, remember what does a derivative mean? A derivative is the slope of the tangent line. But if you're dealing with a line, then the derivative is the slope. It's the same as the slope because a tangent line would fall like on this line. I guess you wouldn't even have a tangent line because it would just fall right on the line. A tangent line touches at one point. But anyway, if you have a line, better to say this, if you have a straight line, the instantaneous rate of change is the rate of change. It's the same thing. So we just got to get the slope. All right, so this is going to be 2, and then I need the slope over 5. So for this slope, I could just do like rise over run. All right, so I've got like this little point. I've got that point here. And I got to find like another nice point. I guess I could use those two. I go up. Make sure the scale is all ones. Yeah. I go up 1, 2, 3, over 2. So 4 over 2 is 2. Oh, I could use that point. Up 2, right 1. So that's. Okay. I apologize for the blurriness. Oh, this camera. Okay. Now, this is number 12. Okay. We're going to do the same thing, except we're using a table. All right, so this is number 12 right here. And I'm only asking you to do the odds. So we're finding this limit, and we're given this table of values here. So first you try direct substitution. So this is 2f of 6 minus, I'm plugging in 2 there, so that's 12. I'm plugging in 2, so that's 20 minus 20. All right, so I'm getting 0 down there. Okay, so I'm getting 0 on the bottom. Now, to use L'Hopital's rule, I also need 0 on the top. So I need f of 6. So the f values are in this column. I go down to 6, so f of 6 is 6. So that's, yeah, that's 12 minus 12. So 0 over 0. So then I say, therefore, by LHR can do for practice. All right, that's L'Hopital's rule. And then I'll just say that this equals, and I will skip, I guess I'll skip this part, this optional step, all right? But do it if it helps you. So L'Hopital's rule says I can take the derivative of the top over the derivative of the bottom. All right, x approaches 2, which I just want to point out, taking the derivative of the top over the derivative of the bottom is not the same as taking the derivative of the whole thing. To take the derivative of the whole thing, you would need quotient rule. All right, so L'Hopital's rule is not taking the derivative of the function itself. Okay, so the derivative of the bottom is pretty easy. That would be 10x minus 10. All right, the derivative of the top, I know like this minus, after the minus is going to be 6x. All right, but I need the derivative of this term, which I'm going to need chain rule for. You don't have to do the chart if you don't feel it necessary. So the inside is 3x, the outside is 2f of blank. 3 coefficients just come down. F prime of blank. 3x goes back in. So this is 6 f prime of 3x. All right, then you direct substitute again. So 2 is going in. So this is 6 f prime of 6 minus 12. Oh, wait a minute. Did I do something wrong? 10x minus 10. No, I don't think I did. Oh, never mind. This is working. All right, and then this ends up being 20 minus 10. So that's just going to be 10. So 6 times f prime of 6. So the table's nice. We don't have to really do anything. We just look at it. So here's the f prime column. F prime of 6 is 8. So that's 6 times 8 minus 12. Okay, I'm just using a calculator. 6 times 8 minus 12 is 36. 36 over 10. I mean, you could leave it. I'll just go 3.6, or you could reduce it. All right, guys, there it is.